We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India.
हेलो, आई एम विशाल पटेल। यहाँ पे मैं आपको सिखाने जा रहा हूँ लाइबनिज लीनियर डिफरेंशियल इक्वेशन। ओके, ये फर्स्ट ऑर्डर लीनियर डिफरेंशियल इक्वेशन जो आपका चैप्टर है उसका ये इम्पोर्टेंट टॉपिक है। इसमें आपको एक पैटर्न फाइंड करनी है कि कैसे आपको सॉल्यूशन फाइंड करना है। After verify pattern, it's easy to find the solutions. 80% केस में लाइबनिज या बर्नौली का एग्जाम्पल आपको एग्जाम में मिलेगा। तो पहले तो पैटर्न आइडेंटिफाई कैसे करें। ओके, हाउ टू आइडेंटिफाई पैटर्न। ओके, सी हियर, इफ द इक्वेशन इन द फॉर्म ऑफ dy by dx plus pxy equal to qx, where p and q are function of x or any constant, means you have to check y के साइड में जो भी होगा वो भी x के फॉर्म में होना चाहिए या कांस्टेंट होना चाहिए। सेम वे इन द राइट साइड द फंक्शन should be terms of x or any constant. If you find such a pattern, then you feel that this is the pattern of example of Leibniz linear differential equations. After finding the pattern, it's easy to find the solution. In that case, you have to see y के साइड में होगा उसको आपको बताना है px, राइट साइड में होगा उसको आपको बताना है qx. Okay, after then you have to find the integrating factor. Integrating factor equal to e raised to integration p dx, and the solution is fixed. Solution is y into integrating factor equal to integration q into integrating factor dx plus c. यहाँ पे आपको जो इंटीग्रेटिंग फैक्टर की वैल्यू मिली हुई है वो वैल्यू आप सॉल्यूशन में सब्स्टिट्यूट कर दीजिए। मींस यहाँ पे तो आपका कोई चेंज नहीं होगा, बट इन राइट साइड यहाँ पे आप वैल्यू सब्स्टिट्यूट करोगे तब आपको पहले q सब्स्टिट्यूट करना है, उसके बाद आपको इंटीग्रेटिंग फैक्टर सब्स्टिट्यूट करना है। q कहाँ से मिलेगा? इन द राइट साइड दिस वन, दिस इज योर q। तो सब्स्टिट्यूट द वैल्यू ऑफ q हियर एंड you have to find integrating factor using p. Okay, substitute value here and substitute integrating factor here and solve this one. You are able to find the solution of given linear differential equation. Okay, अब हम एग्जाम्पल देखते हैं सो आपको पता चले कि कैसे एग्जाम्पल हो गए एंड हाउ टू फाइंड द सॉल्यूशन ऑफ दैट एग्जाम्पल्स। ओके, फर्स्ट वन, सी हियर, इफ यू आर गिवन फाइंड द सॉल्यूशन ऑफ dy by dx plus 1 upon x square y equal to 6 into e raised to 1 upon x। देखो, अब आपको यहाँ पे कोई पैटर्न दिख रही है या see dy by dx plus something y। okay, yes, right, y के साइड में जो भी गिवन है वो x के फॉर्म में है और राइट साइड में गिवन है वो भी x के फॉर्म में है। तो आपको पता चल गया नहीं यार, ये तो लाइबनिज मेथड का एग्जांपल है। ओके, तो आप क्या करोगे, y के साइड में जो भी होगा उसे आप बताओगे px। ओके, आपको px मिल गया, दैट इज योर px इज 1 upon x square एंड राइट साइड में जो भी होगा उसे आप बताओगे qx. Now what is your qx? Your qx is 6 into e raised to 1 upon x. Means हमें px भी मिल गया और qx भी मिल गया. Now you are able to find the solution of given equation using Leibnitz method. Okay. After verify and find the px and qx, the first step is you have to find integrating factor. Now how to find integrating factor? That already we discussed. You have to use a p to find the integrating factor. Now just substitute value of p in the formula of integrating factor. Here integrating factor equal to e to power of p dx. Now what is your p? Your p is 1 upon x square. Now here I substitute the value of this p here and it become e raised to the 1 upon x square dx. E raised to integration of 1 upon x square dx. Now what is the integration of 1 upon x square? It's a common that everyone know. The integration of 1 upon x square is minus 1 upon x. Oh, we find integrating factor. Now it's easy to find the solution. The solution is y into integrating factor equal to integration the bracket q dot integrating factor dx plus c. We already find the integrating factor. So substitute your integrating factor here. Okay. Also integrating factor here. And you have to substitute value of q here. We have all the values. We have an integrating factor, that is this one. This is also integrating factor, that is here. And q, where is q? Yeah, we know this is your q. Okay. Now just substitute all the values here. Y into integrating factor e raised to minus 1 upon x, that I substitute here, equal to integration 6 into e raised to minus 1 upon x, that is your q, into integrating factor e raised to 1 upon x dx plus c. There is no change here. Okay, that keep it is same it is. Okay, now just we have to find the integration of factor this side. But oh, it's a beauty. Both are the same power e raised to e raised to. So the common rule take the addition of the power. And it's become minus 1 upon x plus 1 upon x. So it's become e raised to 0. And what is the power of e raised to 0? Oh, that is 1. So only remain here only 6. Okay. So now we have y into e raised to minus 1 upon x equal to integration 6 dx plus c. Okay. Now y into e raised to minus 1 upon x equals to 6 is a constant you can take outside, or integration 1 dx that everyone know. The integration 1 dx is x. So the solution of this one is 6x plus c. Okay, that is our required solution. This is the solution of given differential equation. Okay, using the Leibniz method, we find the solution of given differential equation. Right? Now, how to recognize and how to find the solution using Leibniz method? Okay, we also solve another example, so you feel the beauty of this method. Okay, see here the next one. Here given a dy by dx minus y equal to e raised to 2x. Just see here, the coefficient of y is any constant. Okay, we have to form of dy by dx plus y. So take the coefficient is minus 1. So our px is minus 1. Oh, we can say it's a negative 1. Now in the right side, given whatever that we call a qx. Here qx equal to e raised to 2x. Now it's a good thing for us that we identify the method. This is Leibniz linear equation, and we find the px, we find the qx. Okay, now we are able to find the solution. After finding the px, we have to find integrating factor. Now what is your integrating factor? Okay, integrating factor equal to e raised to integration power e raised pdx equal to e raised to integration. What is your p? That is your minus 1. Okay, now integration of minus 1 dx, that is your minus x. Oh, that's a good for us. We find integrating factor, and this is a Leibniz method. So just substitute the value in given a solution format. What is this format of the solution? The format is y into integrating factor equal to integration q into integrating factor dx plus c. Substitute values here. Substitute integrating factor. This is your integrating factor e raised to minus x that I substitute here. Now what is your q? Q is your e raised to 2x. This is your e raised to 2x. Now what is your integrating factor? This is your integrating factor e raised to minus x dx plus c. Similarly here you have to take the addition of e raised to power. It's a 2x minus x. 2x minus x become e raised to x dx. No change in the left side, so we have to continue this portion. Just we have to do the change in this side. Okay, it's a become e raised to x dx plus c. Right. Now what is the integration of e raised to x dx? Oh, it's too easy. E raised to x dx equal to e raised to x. Now this is the solution of our given equation. Y into e raised to minus x equal to e raised to x plus c. Oh, we find the solution using Leibniz method, and this is too easy to find the solution using Leibniz method. Students can find such type of example in exam. Just you have to identify the example is Leibniz method or not. After identify the method, it's easy to find the solution. You know here just only beauty of this method, just find the px, qx, integrating factor, and substitute value of integrating factor. Here you are able to find the solution of any of the equation in the format of Leibniz linear differential equations. थैंक यू। नेक्स्ट लेक्चर में हम लोग देखेंगे बर्नौली इक्वेशन।